So again, we are asked to find f inverse. And so when we're done with all of this, we're going to have f inverse equals something. And then we're asked to graph it and find the graph for it. So in order to do this, we have to start, and I say f of n, but it really should be g of n. But we'll just do x. It doesn't matter what the variable is, because we're going to graph this in decimals when we're done. So if I say replace, in this case we're going to replace g of n equals y. So we're going to have to replace that. And maybe I should change this. I'll just change this real quick to n for the funsies. I guess we can do that. But remember, when we go to graph it in decimals, we'll have to go back, and we can only use x in decimals. So anyways, so right here I have g of n. I'm just going to replace that with y. Minus 4 plus 3 over 4. And I'll make that a little more prominent. Step 2. In this case, we're going to solve for n equals some stuff. So I like to say n equals some stuff, because that means in order to get n on one side of the equal sign and all the other stuff on the other side, that means I'm solving for n. I'm getting n by itself. So to do that, I'm going to add 4 to both sides. And I get y plus 4 equals 3/4 times n. Now, the next step is I want to get rid of this 4. So I'm going to multiply by 4 on this side, and whatever I do on one side, I got to do on the other. Okay? So 4 divided by 4 is just 1. On the right side of the equal sign, I'm going to have 3n. On the left side of the equal sign, and I just want to double check and make sure that I set this up the same way that it is in, yeah, they leave, okay. So what I'm going to need to do is I'm going to need to distribute the 4 through the parentheses. So 4 times y is just 4y. And then 4 times 4 is a positive 16. Okay. Next, I'm going to divide by 3. But one thing we could do is we could divide, you know, whenever you divide one term by 3, you can divide you have to divide every term by 3. These 3's will cancel in the sense that 3 divided by 3 is 1, so I'm left with n. And I've got 4 y equals, or not equals, 4y over 3 plus 16 over 3. Now on this one, this will be kind of fun. I'm going to flip-flop the n and the y. And we're used to flip-flopping the x and the y, but it doesn't matter. So then this becomes 4n over 3 plus 16 over 3 equals y. Last step. We are going to plug in our f inverse notation for y. So up here, I'm going to have f inverse of n is equal to 4n over 3 plus 16 over 3. Okay, let's graph it in decimals and see if I'm right. And like I said, we can't use n, we have to use x. So I'm going to say negative 4 plus 3 divided by 4, and I have to use x instead. And let's change that so it matches the colors that I want it to. So let's make this blue, because that's what we had. And then the next one, we're going to do 4 divided by 3. And I'm going to use x instead of n, plus 16 divided by 3. And we'll change the color on that. Okay. And so that's what I have so far. But the interesting thing is, and we'll save this over here. In your because this is multiple choice, although your actual test may not be multiple choice. Actually, I'm gonna help you guys, because this became an issue with some kids when we went over one of these other examples. So I would just want to show you what I'm talking about, and we'll go from there. So your multiple choice file for this particular problem, it kind of looks like this, right? Now we see that B has the right equation, right? Oh, and it's not F inverse, it's G inverse. Good catch. Right, because this is G, although I guess it doesn't really matter, but it does matter because we have to make sure that this is the inverse of G, right? So they should have the same letter. So, but anyways, this is the right function, but what was funny is in class, kids kind of said to me, Mr. Adams, that graph doesn't match, or it doesn't look the same, right? So if maybe you're zoomed in like this, and the kids were like, that's not even the same graph. And I had to remind them, look at the numbers, okay? So they thought the graph was wrong, and I said, no, it's right. And I said, look at the numbers. If you notice, the maximum y value on the graph is 6. The minimum y value of the graph is 6. And the same with the x. The minimum is -6, and the maximum is 6. So it's a -6 to 6 kind of grid. But over here on my Desmos, I go from 20 to -20. So what I need to do is just kind of zoom in until I get to that -6, right? And so I'm counting by 1, and you just got to slow down your brain a little bit and go 1, 2, 3, 4, 5. Well, this is 6 right here, even though it's not labeled. So that is what I'm going to be looking at, and try to imagine what that would look like. Okay, so what I'm really focusing on when I look at this, I got all kinds of stuff going on. Now I gotta wait for the calculator to finish. I wonder if it'll close now. That was weird, it just came on by itself. So what I'm really looking at is this window from -6 to 6. So I go to 6. This is what I'm really interested in, just one beyond the 5s. Actually, that's not enough. I got to go one beyond, so we're going to go up here. So this is, see that little window? That's what I got to look at and see if that looks similar. And so now, because I've made the scale the same, and you could see now that it is almost identical, right? Can you see that? And so that is the correct answer. And so let's label that real quick. So this would be G inverse of N. And this is G of N. And the way this would work is this line right here is kind of like y, and we do this in science all the time, and this would then be the n-axis. It's a little weird, but that's how you would do it. It doesn't always have to be x and y. We could pick any numbers or any variables we want to represent the x and y axis, or in this case n and y. Ironically though, on the graph here, notice that it has x and y. I always like to find the little errors that the publishers come up with.